prices in 2008, 2009 were up around $4. Now they're not up that high. Daniel Yergin, who's a famous oil analyst, has a new book out, Peak Oil. Let's not panic about it, all right? So as long as oil is there, is that affecting the rise of what we saw in the electronics design world in the last couple of years, which was we got to get more efficient. We got to get more efficient. We got to get smaller. We have to have smarter processing power and smarter sensors to better manage our carbon fuels. Is that starting to ebb with the fallback in oil prices? Are you guys seeing that?
The cost of oil and the availability of oil, it may accelerate things or heighten our awareness, but we have so many other problems other than just the cost of energy that need to be addressed, such as the reliability of energy, CO2 emissions, emissions, etc., that I don't see a very tight connection between the price of oil and how much companies are investing in smart grid green energy solutions.
John?
I agree with that. I mean, if you look at the United States alone, for example, we consume nearly 20 million barrels of oil a day. 20 million. And so you look at that number, we only produce 6 million in the U.S., and we're importing 14. So our import rate is almost 70% right now. That's a very precarious position for this country. And if you take a look at, just all of the defensive techniques that we have to take in order to secure oil supplies, I think that regardless of the price of gas, it's something that has to be looked at seriously. And our government has put in CAFE regulations, corporate average fuel economy, specifically in an attempt to address or start to curb oil demand, going forward. So looking at 35 mile per gallon vehicle requirements, I forget the date, but it's in the next 5 years. So I don't see where the price of oil or gas has an immediate effect on reducing the opportunities for sustainable technology.
I know firsthand driving the Volt around the country, yes, we have 110, 120 plug, and you can plug in anywhere, but the infrastructure for fast charging isn't there.
That's right.
It is here. We heard about that this morning in our little media day thing, but generally, it's just not there.
That's right.
Not necessarily in the EV space, but in general, there's a huge emphasis on depending on the region of the world, either upgrading infrastructure, and now I'm talking about protective relays, transformers, substations, all that stuff that is involved in the delivery of power to the consumer, or installing new capacity, new infrastructure, whether it be in developing nations such as China or India. So if anything, I would say that's actually moving ahead faster than some of the things that's getting a lot of press, such as EV charging stations, smart meters, devices in the home that allow you to monitor your consumption. I mean, all those things are great things, but I think behind the scenes there's a lot of I don't know what to call it, big iron infrastructure going in that just allows utilities to operate more efficiently.
You can potentially use electric vehicles that are plugged in overnight, for example, to improve the reliability of the grid, because you could turn these EVs into potentially stored power sources in case if you have a grid outage, and you can potentially have depend on those potentially to provide additional power delivery. So it's not. What's interesting is you can almost look at. We just recently, for example, had power outages here in the Northeast thanks to a hurricane, and you could almost think of a plug-in EV being designed where it could potentially supply power to my home if I lost power from the grid. So I think there's other opportunities beyond sustainability in building fast chargers and potentially having the ability to push power back into the grid in situations where the grid is having a brownout. And if it's got, so let's say the grid is potentially heading for a brownout situation, and you've got 1,000 volts that are plugged into the grid currently, it'd be awfully nice to be able to pull some of that power back temporarily to avoid a brownout. I mean, these are some of the more innovative ideas that a vehicle like the Volt could potentially allow us to achieve.
So you talked about brownouts, right? So there are government regulations that the utilities have to comply to so that there are no brownouts, right? They need to anticipate these things and have the smartness in place to prevent these brownouts, right? And again, just like the auto industry, if you go back in time, 30, 35 years ago, regulations on emissions drove the adoption of electronics in the automotive industry, right? The car regulations from the early 70s. And that's what led to the whole explosion of electronics that you see in the automotive industry. And the same thing is true in the electric utility industry as well. These regulations and the changes will drive the adoption of smart grid, smart meters, and that electronics kind of allows you to manage both the power demand and the power creation, right? And make sure that they're always in balance. And that's where the electronics and the software that controls the electronics comes into play, and that becomes the real critical piece of it, to make sure that that works right, it's designed right, and it always works right.
I want to bring Chuck up because Chuck was one of the most interesting early interviews we had on this Drive for Innovation. And I want you to talk a little bit about battery technology, because that's the question that we get most often.
The big thing we're seeing is that the industry has a long-term goal of $150 per kilowatt hour for a battery. Right now, we're in a situation where it might be 4 or 5 times that much. So we've got a long way to come down. Secondly, the energy density has a long way to go up. Not as far as the cost, but right now we're at about 140, maybe 150 watt hours per kilogram. We want to get up to 300 because that affects the range of an electric vehicle. We've talked a lot about this, and Brian mentioned Moore's Law. One of the beliefs that comes out is that battery technology will advance the way Moore's Law has. But that's, I mean, no less than Bill Gates has said, we've been spoiled by Moore's Law. So there's going to be an issue bringing those costs down, bringing that energy up, because it's not going to be on a Moore's Law curve. And again, as Brian had said, we heard a lot of this 20 years ago. When I started writing about electric cars before 1990, we heard about 400-mile range and 15-minute recharge times are just a year or two away. We've gone now 20 years, 23 years, I think, since the first article I did about electric vehicles, and that hasn't happened yet. Now, can we do advancements? Yes, but I think the path is kind of unclear, and I would love to hear from any of the panelists here about whether we see that happening, whether we see that high energy density happening, whether we see that low dollars per kilowatt hour figure, particularly the 150, which I think we're a long way from right now. Can that be done?
Does anybody know how many kilowatt hours are in a gallon of gas? Anybody want to guess? The answer is it's 30 kilowatt hours in a gallon of gas. Okay, that's the equivalent energy density. And so, does anybody know how many kilowatt hours are in your volts in terms of its pack? I can tell you the answer to that. It's 16. It's 16, but only like 11 is usable. Right. So it's only 11. So your volt is only carrying the equivalent energy density of 1/3 of a gallon of gas, or maybe about 1/2 to 1/3 of a gallon of gas. And that battery pack cost $12,000, I think. It's something like that. And I think it weighs 500 pounds. I forget the exact number, but it's that order of magnitude. And a gallon of gas weighs, 7 pounds. It gives you some idea and perspective of the energy density of fossil fuels versus batteries. So we are like 2 to 3 orders of magnitude away in terms of the weight equation that you were talking about earlier, in terms of energy per weight, of really supplanting gas as a means of total replacement, as far as I see it.
I want to ask you about the design chain, the supply chain, the speed at which solutions in the automotive or the green energy space are designed. Because in the digital consumer space, you can do things in a matter of months, right? You guys grease that skid all the time, right? You're in the business of simulating extraordinarily complex things quickly so people can get to market. Is it a different dynamic?
We would all agree that it's much more complicated to simulate the grid of the whole, east coast of the U.S., right? And that probably is more complicated than simulating a whole car, and that's probably more complicated than simulating maybe a piece of cell phone or something like that, right? So I think there are just those, engineering complexities that are involved in designing these systems. I think the attitude change that's happening, especially like on the car companies that has happened over the last 10, 15 years, is that move away from having to try out everything using physical hardware to just the notion of trying out ideas using simulation, right? Because that gives you that big speed up, where the vehicle development programs used to go maybe 4 or 5 years out, and people are looking at shrinking those. We are now down at 2.5 years in some cases, and we want to keep pushing that down, further down. And I think that's where simulation technologies play a key role, because it allows you to collaborate across the supply chain. People can exchange their ideas through these simulation models. You might be an engineer in Brazil. You can take your component model, give it to the engineer at GM in Detroit, and they can simulate the whole car and see how the component changes can affect the overall, GM world performance, right? And that is playing a big role in speeding up the development process for the car companies, for sure. And certainly we see that migrating now onto the electric grids and things like that as well.
Many of the same concerns still exist, and those are, primarily can be cost, and then certainly time to market and getting product out to the market, as quickly as possible. We talked a little bit about design chain and some of the enablement tools, that we have available through Avnet Express. Recently we had a nice success story up here in the New England market, where we had a low power design. They were using some ARM technology, had very little familiarity with that particular technology. We brought in a team of this particular company's engineers and did full couple of days training at our facility to help them with their time to market and giving them the enablement tools that they needed to get their product up and running. Mm-hmm.
So what's the future of fuel cells? Is it the destination we should be heading for, or what should be the destination in terms of our known technology? Mm-hmm. And where are we on that road?
It's about having all these different options, right? Be it fuel cell, be it hydrogen fuel cell, be it electric plug-in or whatever have you. I think there are a lot of changes going on, and if you're a car maker, you want to be ready to in a position to evaluate all those different options, right? And be able to be ready when the market does shift in the way of one of those technologies.
I was looking more in a prospective development of energy, policies and technologies over the next 20 years, 30 years.
The big challenge with fuel cells is hydrogen. I mean, hydrogen requires, first off, it doesn't really occur naturally. I mean, it's not something you can easily mine. You can convert natural gas to it at a moderate efficiency, or you can make it from electricity, but the conversion efficiency is very poor in both cases in terms of energy density. The bigger problem with hydrogen is containment. You end up with containers where it has to be pressurized at about 5,000 psi. So you got to be carrying this container that is literally 5,000 psi. So think about the design that so it survives an accident, and the nice New England salt that we get and all that wonderful stuff. So that kind of limits your range, and then and it also impacts the efficiency quite a bit too. Yeah. The fuel cell themselves are using some rare materials, such as like palladium, for example. So the manufacturing costs on the fuel cells are still quite high to do roughly 100 kilowatt or so converter, which is, I think, is what's in the FC Clarity. So that FC Clarity, I think, costs several $100,000. I forget the number, but that's the vehicle cost right now with the fuel cell, and hydrogen has the real challenge in its storage, and it has issues like you have to worry about outgassing it at times when it gets hot out and stuff like that. So there are quite a few challenges with that. So fuel cell may have some places, but I'm not convinced. At least I haven't seen the data yet that shows that it's the answer tomorrow. I don't know if that's your question, but
well, no, that is a large part of my question, and that answers a lot. Thank you. So if we're looking 20, 30 years out, what currently seems to be likely to be the winner, or one of two winners 20, 30 years out?
I think it all hinges on battery technology. Okay. The big problem we have right now is we don't have batteries that have high energy density per weight. That's the fundamental issue.
Okay.
We're 2 to 3 orders of magnitude away from having a battery that weighs 7 pounds and stores 30 kilowatts of energy. That's where you have to look at, because that's your car equivalent right now, and to do that cost effectively. So that's your EV vehicle, where you got to get to. So it's an enormous opportunity for the battery manufacturers. I haven't seen the density improvements to the level of Moore's Law. I mean, it's gotten maybe 2x better, 3x better, thanks to lithium technology in the last 7 years. But it's really a struggle.
So let's step it up a little bit, right? Because we've talked about battery technology, and the right solution is years away, whatever that right solution is. We're in a fascinating transitional time, and it's great to cover and talk about. But there are other things. There's vehicle-to-vehicle communications. There's internet-to-vehicle communications that your customers are engaged in right now. Tell us a little bit about what you guys, whether it's John or Samir or Ron, what are you guys seeing out there that is solving the wireless problem, the smarter car problem? Because it doesn't really matter what the motive force is there, right? It's a different design problem, and it's fascinating.
The smart highway system, I think they developed one in California, if I remember correctly. And so that had, I think it was magnets that were installed in the, along the lanes. But that was done primarily to make sure that vehicles didn't change lanes for safety reasons. But it also had the ability to improve traffic flow. And this is the thing that people don't realize, is that you can get a lot more cars. Like, you look at congestion that we have, and a lot of congestion is because people are reacting slowly to changes in traffic dynamics. And if you can automate some of that, you can actually get a lot more cars down the highway per hour, and you can eliminate congestion. And so there's been a number of study projects that are actually looking at, are there ways we can eliminate the drivers, turning to change lanes, they're accelerating and decelerating haphazardly while they're on a highway, and control that better. Because if you can get a lot more cars down the highway without building new roads. It's kind of fascinating, without widening the highway.
When you're designing in, whether it's the automotive area or the smart grid area, what sort of pressures are these teams under? And is it any different than the traditional, cost, size, power management issues?
They really need to do a very good job of integrating the whole system, right? There are a variety of different systems on board. Even if you talk something as simple as the adaptive cruise control thing that John mentioned, right? It has to tie in the braking system, the acceleration, it has to tie in all the sensors that communicate with the different module on the car, then the powertrain module. And that's where I think this whole notion of integrating these systems becomes a key design challenge. And it becomes worse when some of those modules can come from a different supplier. And how do you know that you designed it right, and then did you build it right? And that's a significant challenge that a lot of the OEMs and the suppliers face today, right? And in all these examples we're talking about, right? John mentioned that we could pack those cars much closer together because the control capacity is there, where the cars can be packed really close together. Nevertheless, if you're a driver, you get nervous, and there are studies that have been done that show that drivers don't like that. They would rather, stay back, right? So that notion of safety critical, if I can call it that, is really, really important, right? How do you make sure that when you pack it that closely, the driver, you cannot take the driver completely out of the loop, because there will be some unforeseen situations where the driver might need to intervene, and kind of taking all these possibilities into account upfront in the design process, running through all those scenarios, that's a big challenge. And I think that's what the customers that we work with, that's what they're faced with. And from our perspective, that's where they see a big bang for buck for trying out all these concepts in the virtual world through modeling, as opposed to kind of putting all those components together and trying it out and then seeing if it works or not. I mean, that's what we see.
Design teams are running very lean, and they're looking to their suppliers for more and more innovation and expertise. And what that means is that suppliers need to really extend themselves outside their comfort zone. So, for example, as an IC developer, we no longer can be comfortable just being experts in designing ICs. If we're going into the automatic highway application, for example, we need to become experts in that and really embed that expertise and innovation into our products. And that's a big challenge for any company.
In your world, green energy, automotive electronics, whatever, and I'll start with John. Sure. What's the coolest innovation you've seen in the last year?
So we're starting to see, we talked already a little bit about trends in wireless technologies, wireless communications, also low power designs, and as well we touched upon lighting and high bright LEDs. And one of the cooler things now that we're seeing is someone that's integrating high bright LEDs inside of a fixture and controlling that through wireless communications. So taking advantage of the low power and the high bright LEDs, and certainly using the wireless communications to be able to control that. It's a pretty neat application.
Thanks, John. Now we'll go to Samir. What have you seen among your customer base? They're working on verifying very complex stuff.
So I think I'm going to take a slightly different tack at this, which is I think the coolness of technologies is just amazing out there. I think I want to build on what we were talking about earlier, which is this need for engineers with multidisciplinary experience, if you would, right? Somebody who knows radar, somebody who knows 40 years ago, a car engineer would be a mechanical engineer, and now you need mechanical, electrical, computers, software, radar, you name it, right? It's all there. One of the coolest thing that I've seen happen is kind of going this downstream onto the education university side, getting the students interested in engineering and giving them that experience of a full-fledged engineering career. The example I want to use is that of EcoCar, which is a competition run by US Department of Energy along with GM. And the students actually get to design and build a alternative energy-powered car when they're in school, using the same development process that GM uses. I think that is really, really cool. I wish when I was in school, I had that experience, because it just makes you so much more equipped to go into industry and continue to drive kind of the innovation process further. So to me, that's the coolest thing that I think I've seen and I've been involved in. And I would really like to see more of that in all the other industries, be it the electric utilities or any of the other areas, where we really reach out into the education university area and really try to get that next generation of engineers and scientists trained so that they can help us innovate more and more.
Good perspective. Ron, coolest innovation?
Yeah, the coolest thing I saw probably is not going to sound very cool. But maybe I need to set the stage a bit. And what you need to realize is that when an electric utility generates power, they have no idea who's going to use that, who is using that power, the route it's taking to that source, and if a tree falls in a storm and knocks down a power line, they don't even know that happened unless someone sees it, picks up the phone and calls them. So the coolest thing I saw is one of our customers who develops smart grid solutions came to our facility. They connected their laptop to the network, and they asked for a 6-digit number. And 1, 2, 3, 4, 5, 6. Type it in, and it pulls up a substation somewhere in California, real time. And immediately, within a couple seconds, we could see what's going through that substation in terms of currents and voltages, the way it's being distributed, and so forth. And it might not sound as cool as the MEMS thing on the hockey helmet, but for someone kind of working in the utility industry, it made a big impression on me as a big step forward.
I like it. John, you're up.
I think one of my favorites, and it kind of dovetails into this, is a company I've had the fortune to work with that does a Wi-Fi thermostat. And so I installed one of these in my home. You can buy it at Home Depot, by the way. It's under the 3M label, so it sells for $99. And looking at the whole sustainable energy, I just think it was one of the first applications that I saw that really made sense to me. Because I could basically be on my phone, and if I decide that I'm coming home early, I can turn my air conditioning on or my heating system on, or if I'm on vacation, I can automatically turn those. I mean, how many times have you left your house and said, oh, I'm going to be gone for 2 days, I'm on a business trip, why not lower my temperature? But it's too late, I'm already driving to the airport. Or I'm coming home early today, and I'm sick of my house being, 50 degrees when I get home. Well, let's turn it up to 68 degrees now. It'll be warm when I get there. So to me, that was the first smart energy thing that I felt that a customer could see immediate benefit on.
So here's hoping we all keep it up. We keep inventing the future. And I want to thank our panelists. Let's give them a round of applause.